Hello everyone. I'm going to now move on to the first uh, external module that we are going to discuss. So this is the second video, and we are going to discuss about Numpy, the basics of Numpy, what we can do using Numpy module. And the other thing is that these codes are available to you. So the first video, you have these links to these codes, so you can go there and download these materials and uh, get these materials and see the codes, right? So let me open the NumPy tutorial IPython notebook, right? And we are going to discuss now about NumPy. So NumPy is the numerical Python module. And if you have heard about MATLAB, something called MATLAB, so NumPy together with matplotlib is quite equals to the MATLAB software, right? So everything that you can do in MATLAB can be done in Python using NumPy and Matplotlib together, right? So NumPy is basically a library designed for matrix operations. So if you are dealing with matrices, that means multi-dimension arrays, right? So then the NumPy is a very useful library for you for those kind of implementation matrix operations, right? Since we are going to move on to like machine learning, deep learning in the coming workshops, right? We always deals with data sets, right? So that means data sets are always multi-dimension arrays. So NumPy is the essential library and an essential module in our implementation, very useful. And NumPy also used in other modules as well, like OpenCV use NumPy for their implementations, and TensorFlow, scikit-learn, all the libraries are using NumPy in their codes, right? So NumPy is a very useful library, so that's why we are going to discuss about NumPy in this tutorial, right? So we will go to very basic things and see how NumPy can be used for our applications, right? So here you can see we import the NumPy as NP now. This is what usually this is the name that we are going to use for NumPy and get it to customize name, so NP. Then, right, so the first thing, how we can create a NumPy array, right? So NumPy array is simply a multi-dimension array object available in Python, right? So here you can see this is a Python list, right? So you can see a Python list here, and this is a two-dimensional list, and it has like 3 rows, as you can see, 3 rows and 4 columns, right? 4 columns and 3 rows. So this is a multi-dimensional array, but this is a Python list since you have the square brackets, right? So this can be identified as a Python list. So Python list, we can't do anything using Python list when it comes to machine learning, deep learning, and everything. We have to have multi-dimension arrays. We have to convert it somehow to a NumPy array. After converting it to a NumPy array, that means if you have a NumPy array, that will be a huge benefit for us since we can do lots of things using NumPy arrays. For example, we are going to discuss about images in OpenCV. So images are loaded into Python as NumPy arrays, and also the neural network architecture, they are weights and biases, so they are also NumPy arrays. So NumPy arrays are used everywhere. So if you are going to deal with the data set, and if let's say a data set they are in the Excel file, so if you want to load it to your Python code, then it will be loaded to a NumPy array, right? So NumPy arrays are always there, multi-dimensional arrays. So when you have a Python list or anything, you have to always convert it if you are dealing with some application related to machine learning or deep learning or image processing, you have to always convert it to a NumPy array. It makes your life easy, right? So that's how we are going to convert it to a NumPy array. The method is np.array. So we are going to call the array method in NumPy, and we pass this array. So what happens? This simply convert this into a NumPy array, right? So now you can see that if you print this and run, so the array one, that means the original one is a list like this, but here the array one new is the NumPy array. So we pass this one and we got a NumPy array as the result. So NumPy array, you can see it's kind of a bit different, right? So compared with this, the elements are the same, right? The elements are the same, but this is a bit structured manner and it looks like a matrix, right? So that's how simply you are going to convert a normal Python list into a NumPy array, right? And also you can like, let's say you have a single dimension array, you can also you can convert that into a NumPy array as well, right? But anyway, yeah, so this is how simply already existing list, this is how we are going to convert it to NumPy array. And NumPy arrays, they have very important attributes. So the shape and ending. So we are going to discuss about shape and ending. So if you have a NumPy array, we can check the dimensions of that multi-dimension array. So we know matrices, multi-dimension arrays. So they have dimensions, right? Or you have a shape. So these are the two attributes that we can use to check the shape and the dimensions of a NumPy array. So what you can do is, okay, now we have, let's say we have a NumPy array like this, and if you call array dot, that array name dot endim, that gives how many dimensions are there, right? So simply this kind of array, we have only two dimensions, right? So the columns and rows, right? Rows and columns, so only two dimensions. So row 1, row 2, row 3, column 1, column 2, column 3, column 4, right? Anyway, two dimensions. So we have x-axis and y-axis, I mean rows and columns. So that's what you mean, two dimensions. But here, so you can see it's a one dimensional array, a single dimension array. So since it's a single dimension array, we have only one dimension here when you print the n dimension of this kind of array. So you can, I think you can get the idea. So it has rows and columns, that's why you got two here, and this is only having one dimension, like it's a one dimensional array, so that's why you are getting one. And the most important thing is the shape. So you can see when you print the array one dot shape, array one new, this NumPy array dot shape, it gives exactly the dimension, like, okay, it says 3 rows and 4 columns, right? So obvious, right? So 3 rows and 4 columns. So it gives the number of rows and columns. So the dimensions in numbers, you can use the dot shape, right? Hope you understood. So endim and shape simply gives you, now can you see that it gives you the values in a tuple, right? Rows and columns. Okay, now then we are going to discuss about a very important set of methods available in NumPy. Now these things that we are going to cover under these modules are very helpful, and these are very useful in our future implementation. That's why I specifically selected these things and discussed, right? So you have to get the basic idea. And if you are wondering why we are learning this and we have to apply this, don't worry, just get the idea and get it concrete on your mind. So in soon future, in our practical implementations, in our advanced workshops like machine learning, deep learning, we will use this heavy. Then only you are going to see, okay, these are the applications of these functions, these methods that we have used. But now we just use this and we just get the implementation knowledge. Then the practical implementation and usage of these methods and functions will be there in our advanced workshops like machine learning and deep learning, right? So keep that idea thing in mind. Don't think that, okay, we are just covering these things and go through these things. No. NumPy is a very large library. OpenCV is a very large library. Matplotlib is a very large library. I mean, in order to learn the full NumPy content, it will take like 2-3 weeks or even month. No, we are not going to do that. We will cover only the basics and whatever the things that we need in our implementations in our coming workshops like machine learning and image processing. So we just cover the theory. The implementations and the practical usage of these functions will be there in our advanced workshops, right? So keep that thing in mind. So here we have an array, the similar array, the earlier array. And what we can do is we have a function we can call like the array name dot reshape. So reshape can be used to change the dimension and reshape the array, right? So what we have done here is simply, you can see, okay, the array was, if you print the shape of this one, you can remember the array one dot shape is something like 4 3, oh sorry, 3 4, right? Now we are converting it to 3 4, 4 3, right? So the rows are columns are interchanged. This is not the only thing you can do, you can convert it to like 6 4, sorry, 4 3 is 12, right? So 6 2, right, or 12 1, right? Likewise 1 12, right? Right. So the thing is now, but we can't do these kind of things, right? Like okay, 5 4, no, right? So it's obvious we can't do that since like we have only 12 values here, right? So I mean, the original one we have 12 values, 4 into 3. So somehow you have to keep the total number of elements to 12, right? So you can, with that constraint only, you can reshape, right? So you can do these kind of silly things, right? So the other thing, like you can convert it to so as I mentioned, you may be wondering why we want to reshape. We have to use this heavily in our implementation when it comes to machine learning, right? So that's why we are covering these things. And so keep this thing in mind. We can use this reshape function like this, and we will talk about the implementations in detail in coming workshops. So then the other one is np.arrange. So we can use this np.arrange to create an array using these three values. So this is similar to the loop, right? So the starting value and the ending value and the increment, right? So it starts from -10 to +10 and with two increments, and you are going to get this kind of a one-dimensional array, right? And also when you are going to create arrays like NumPy arrays, when like let's say you are not going to convert it from a list, right? So one method is you can have a list and convert it to a NumPy array, but also we have like array creation routings where we can create empty arrays like this. So the command to create empty arrays is np.empty, and this is the dimensions like 3 and 2. So it creates simply 3 rows and 2 columns array, and the data type you can give it as like np.int, np.float, and whatever the data type you want. But it should be given like np.int, np.float likewise. And the other thing is that empty function just create a array for the given dimension with empty values. So don't worry about that we are having large value here. No, these are not real values. These are garbage values, dummy values. So it says it creates an uninitialized array, specific shape and d type given. So the shape is this and the data type is int. The elements in the array show random values as they are not initialized. Since they are not initialized, when you are going to create an empty array, those will be created as this, right? So then also you can create an array with 0. So simply if you want one dimension array like np.zeros 5, so this creates array with zeros, 5 element one dimensional array. So this is a 2-dimensional array like 5 3. So it creates a float type array of 5 comma 3, 5 rows and 3 columns with zeros, right? And if you change the data type to int, this is what you are going to see, right? So d type and the shape. So when you are going to create these kind of things, you have to provide the shape and the d type, the data type, right? And also the ones, right? So zeros and ones, same. So zero simply creates an array with zeros and one creates an array with one. But don't think that 2s, 3s, 4s, 5s. No, don't think that those kind of live, I mean, methods are available. Not only zeros and ones, right? Zeros and ones, you can create this kind of initialize. You can initialize arrays like this, right? And np.arrange, we discussed about that earlier. And very important topic, indexing and slicing in NumPy. So here you can see that we have created the array, NumPy array with random value. So this is how it's done. Array equals np.random.random integer. Now you may be wondering, okay, we have seen something like np.arrange, np.resize. We have seen something like that earlier, but what you mean by np.random.random integer? So it's like 2 dots, right? So this is what it actually means. So let me quickly change the window to the like this, right? So now sorry about this. Now if you go to the location where the Python installed, and so I'm in the lib and site packages. So let me go to the Numpy, and let me show you. Yeah. So in Numpy, you will see that we have another sub-library called random. See, somewhere here, yes, here, right? So in Numpy, the large Numpy library, we have a sub-library called random. So that's what it means here. So Numpy library, go to the sub-library random dot sub-library called random, and inside that random, we have a function called random integer. So this is like Numpy, again, a sub-module in Numpy called random, and inside that you are going to get this function, right? So that's the meaning of np.random.random integer. So let me quickly come back to the original one. Okay, so we are creating a array with random values, random integer values. So how you can do that? So this is the range of the values that can be appeared in this matrix or the array, right? So all the values that can be there, they can be between 0 and 100. So the limit, the lower limit and the upper limit of the values. And 10 and 5 simply defines the size of the array, the dimensions of the array. Like it's like 10 rows and 5 columns, right? And the values, there can be between 0 and 100. So simply, in one sentence, this creates a array with 10 rows and 5 columns, right? With values in between 0 and 100, right? Understood? So I just create some random values. I wanted to show you a few things regarding NumPy arrays, right? So let me print you these things. So I'm creating an array like 4 and 3, 4 rows and 3 columns, and all the two arrays are in between, having values in between 0 and 100. And then array 1 and array 2. So this is the array 1 simply, and this is the array 2. And here array 1 plus array 2, and I get it to array 3. Now this is the beauty of NumPy. So think about how to do this kind of a thing. I mean, addition of two arrays in C, C++ or Java, right? If you are not using any kind of a library, you have to run like 2 for loops, one loop and inside another loop, and add the each and every individual element separately and do this. But here, single line, right? Array 1 plus array 2. So it does everything for us, right? So it add these two arrays individual element by element and provide you the resultant array, right? So very simple, right? So otherwise we have to go to a loop, two loops, and add these elements of the array, right? But the thing is, now this is element by addition. So this one, this value is added and it's added to here. This one added with this one added to here, right? This one here, and this one with this one here. Sorry, this one with this one. The answer is this. Likewise, individual element addition is performed here, right? And this is again another important thing, right? So we have a array called array 1. So this is the array 1, and I have performed like array 1 divided by 10. So you may be wondering, can we do that like array divided by a scalar? Yes, we can do. So what happens here? All the individual values will be divided by 10, right? So this is what we are going to get as the answer, right? 8, 4.5, 6.6, likewise. So each, I mean, the element wise division is done. So this is not only for the division, multiplication, right? You can see, and also you can like addition and the subtraction. So individual element subtraction is done, right? So keep that thing in mind. Individual element operations can be done like this for NumPy arrays. Now, don't think that you can do this for Python list. No, you are going to end up with errors. No, these things cannot be done with Python list. These are specific properties and attributes of NumPy. So that's what the importance of NumPy. We can use it for, I mean, NumPy makes our life very easy when it comes to these data sets and data sets and also this kind of arrays and matrices, right? Okay, but if you want to get the real multiplication, now you know how the arrays are multiplied, right? So row wise and column wise, so you know the multiplication. So this is how the real multiplication can be done for arrays using matmul, matrix multiplication. So array 1, array 2. So these are the actual multiplication, dot wise multiplication done for matrices, right? And okay, so again we have numpy array randomly. So now we are going to talk about slicing of numpy arrays. So we are going to start from here, right? So we have a numpy array with 5 rows and 10 columns, and we have something like this. And let me, yeah, not 5. Let's say like 3 and 5. Otherwise, it takes lots of time to this. Oh no, we will do it for like 5 and 7. Let's say 5 and 7. Okay, 5 rows and 7 columns, right? So now this is a bit interesting. I will before going on to that, let me provide like np dot np dot maximum of the array, right? So what simply it does, np dot max, the maximum function, we pass the array here, this array, and what you are going to get is the maximum value of this array, so 99, right? And we can use like the same minimum, right? So you can get the minimum value and you can get the summation, right? And everything is applied, like mean, you can get the mean of this array, right? So very advanced things can be done using one line. And the other thing is, okay, let's go to the max, and we have another thing called argmax, right? So these are very useful in our future implementations, right? So can you imagine, so if you run this again, max and this, so this gives 12. So what it means, that means the argument or the index of the maximum value. We know the maximum value is 12, but argmax gives where the maximum value situated. So 0, this is the first 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it says the maximum value is in the 12th element. 12th element, right? The index of the maximum value, it gives like that. But the next thing, okay, this is the maximum of the array and this is the argmax of the array, but I'm going to add the additional parameter here. Now you know that this is the keyword argument, axis equals 0. When you are going to provide this axis, what happens? You are going to get something like this. So can you imagine what this is? So simply, it's like this. Now we have this kind of we have this kind of axis, right? So this is the axis and this is another axis, right? So two axes, rows and columns we have in our this kind of array, two-dimensional array. We have two axes. So you are asked to like go through the axis 0, right? So what do you mean by axis 0? This is the axis 0 or the x-axis, and this is, so axis 0, and this is axis 1, the y-axis, right? So what you are asked to do, go through axis 0 and get the maximum. I think it's a bit, I interchanged the axes. So this should be the axis 0, and is it? No, no, yes, this is the axis 0 and this is the axis 1, right? So what happens here is simply this goes through the axis 1, right, and get the maximum of each column. So it's go through this axis, for example, like this, it goes through this axis, right, and get the maximum of each column. This column, this column, this column, this column, this column, this column, this column. So that's why you are going to get maximum, like 7 values for the maximum. So this one, this is the maximum. And here, this is the maximum, as I can see. Here, this is the maximum, right? So this is the maximum. And for this one, I think 55 is the maximum. Here, 99 is the maximum. Here, 97 is the maximum. So those are the values you are going to see. So it's go through axis 1 and get the maximum value of each column, right? So that's called the axis 0. And you can remember, you can then, I think you can identify what it gives by axis 0, right? The argmax. So it gives which row, right? So here, this is row 0, this is row 1, this is row 2, and this is row 3, and this is row 4. So it says, okay, the maximum value of the column 1 is in row 0. See, row 0. And the maximum value of column 1 is in the row 1, right? So let's say maximum value is column 6 is in the first element here, right? So it gives the index. So we are going to get the column wise maximum, and the argmax gives which row the maximum value is located, right? So now I think that you can predict what happens in the axis 1, right? So this gives you simply the, right? Yeah, so right? Yeah, so this simply axis 1 simply goes through this axis. I mean this axis, the axis number 1, right? So it's go through this axis and get the maximum of each row. So here this one, 99, 95, 97, and I think 81, right? So likewise, it gives the maximum values of each row. And argmax gives you the index number, I mean the row number of, so okay, 86 in the row column 0. And here the maximum value is in the, sorry, column 6, right? Sorry, column 5, right? And in the third row, the maximum value is in the third column, right? Likewise, so it gives the column number, the maximum, I mean, it's going to go through, it's going to get the row-wise maximum, and argmax gives you the column number of the maximum value, right? Hope you understood. So carefully have a look on this and get the idea what it does simply, right? Okay, so then max, argmax, mean, sum, so you can get those things like that. And yeah, so here is a very interesting thing, right? So you have this kind of array, let's say, okay, 0 to 100 values are here, and 5 to 5 rows and 10 columns. So you have this kind of value, I mean array. So if you run this, okay, so if you run this again, since it's random value, so the elements are changing, right? So can you understand what this simply does now? This is called the slicing. So very important idea in Numpy array, slicing. So what this gives, like, okay, so this comma separates rows and columns. So what is there? The first, this defines the rows. Let me get the red color, right? So this defines the rows, and this defines the columns, right? So here it says row-wise go from 0 to 2, right? So let's say, okay, row-wise 0 to 2. So let me have some numbers here: 0, 1, 2, 3, and 4. Here 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So what happens here? Okay, so we are asking for go to from 0 to 2, right? In rows. The first, before the comma, we define the limit of rows, right? 0 to 2. So we have to go from 0 to 2 in row wise, right? 0 to 2. Okay, these are the 0 to 2 in row wise. And column wise, you are asked to go from 0 to 4. Let's see. Okay, column wise 0 to 4, right? So you can see the highlighted section which covers both, right? So that's what printed here, right? Column wise 0 to 2, row wise, right? 0 to 4. Right? So this is the highlighted section, right? So in the other thing, the remaining one, so we haven't mentioned, here you can see, we haven't mentioned the upper limit and the lower limit of the rows. So that simply means all rows, right? So if you just put the semicolon, that means the upper limit and the lower limit are not given. So that means simply all rows, right? So, okay, so let us take the all rows, right? All rows, okay, all rows, and 0 to 4 column wise, right? So let's say 0 to 4. So 0 to 4, right? So that highlighted section is given here, right? Now we will use these things in heavily in our implementations in coming days, right? And yeah, so what this means simply, can you identify array all rows, fourth column? So no any lower and upper limit given to the columns, right? All rows, you know, colon there, that means all rows, and fourth column, so that means what? So all rows, okay, all rows, but the fourth column, only the fourth column, that means we are only focusing on one column. So that means this column. So all rows, fourth column. So this is the one both covers, right? Understood, the fourth column. And here if we take this one, so what this means simply, row wise, you are asked to go from 0 to 2, right? So the lower value is not mentioned, that means 0, right? If the lower value is not mentioned, that means 0, right? 0 to 2. Okay, so 0 to 2. That means 0 to 1, you know, right? Upper limit will be always less than the given value, right? So here and column wise, we ask about all the columns, right? So what's the highlighted section? So you can see the highlight section is this, right? That's what you are going to see. So this is called slicing. So when there is a data set or there is a matrix, what we can do, we can use this slicing methods to get rows and columns and separated and get whatever we want, right? For example, so if we want like now what's the usage of this? So let's say that you want to get the average of only this section. Yes, very simple. How we are going to do that? You can right, get the np.mean of this set of values, right? Mean, maximum, anything can be taken, right? So we can, so this slicing is a very important thing where we can, when we have a data set or we have a set of, we have a matrix, we can get these columns and the rows separately and we can get whatever we want, right? So that's the usage of these things. So we will heavily depend on these things in our implementations, coming implementations. So we have a very good example given here, right? So this explains how to get the pandas module and how to get a data set read from a CSV file, how to load the CSV file into your computer using pandas. Now we have a data set here. I have given this CSV file to you to practice this example. So there is a CSV file in this location. So I will share this folder with you, right? So this kind of a CSV file, yes. I think student marks, right? So the CSV is there, right? And the CSV, you have this set of names and maths marks, physics marks, chemistry marks. So what we'll do in this simple example, we will use pandas and numpy and do very very interesting thing. We load the data set and we get the two-dimensional matrix, and we then what we do is we calculate the average marks of these subject for each and every student, and then we calculate the grade for each and every subject of each and every student, and finally we calculate the average and the marks, and we create this kind of a data set, right? We read it on like names and 3 marks, but now we have 3 grades as well as the average, and then we save it to a new uh, I think to the new data set, this one, right? So using only NumPy and Panda. So very interesting tutorial. So we will meet with that tutorial on the next video. Thank you very much.